Ever notice how nutrition headlines seem to flip every few years? 1 year, red meat is a quiet killer. A few years later, a new report says the science was shakier than anyone let on. So which one is it? This is not really a story about steak. It is a story about how easy it is for good, honest scientists to look at the exact same numbers and walk away with completely different answers, and what happens when someone finally tries to catch that in the act. For decades, red meat has carried a heavy reputation. Health officials have linked it to heart disease. Some official classifications have placed processed meat in the same broad cancer risk category as tobacco smoke and asbestos. Butter was the enemy, then margarine was, then butter again. Eggs were dangerous for your heart. Then they were fine. Then they were dangerous again, depending on which decade you asked. Coffee has flipped back and forth more times than most people can count. Maybe you have changed what is on your own plate because of one of these swings. Cutting back on red meat after a scary headline, then quietly wondering later if it was even worth it. If you have ever felt whiplash trying to eat healthy, you are not imagining it. Nutrition science genuinely contradicts itself more than almost any other field of medicine, and there is a real reason why. Here is something most people never think about. When scientists study diet, they are almost never running one single pre-planned experiment the way a drug trial does. Instead, they are staring at mountains of survey data, and at every single step they have to make a judgment call. How do you define a serving of red meat? Which other habits do you account for? Smoking, exercise, income. Do you group people into thirds or fifths or treat their diet as one continuous number? Every one of those choices is reasonable on its own. Nobody is cheating. But change a few of those choices, and the exact same pile of survey answers can point toward completely different conclusions. Scientists have a name for this. They call it analytic flexibility, and it has quietly haunted nutrition research for years. Think of it like two people measuring how long their commute takes. One counts from the moment they leave the driveway. The other starts the clock once they hit the highway. Neither is wrong, but they will report two different numbers for the exact same drive. It is a bit like two teachers grading the same stack of essays with two different rubrics. Both graders are being completely fair. They just do not agree on what counts. Now imagine it happening not with a commute or a stack of essays, but with a question that shapes what millions of people are told to eat. This is not some abstract academic argument either. Red meat shows up on plates several times a week for most people, and the guidance about how much is safe helps shape school lunches, hospital diets, and government food pyramids around the world. So a group of scientists set out to actually test how much that flexibility matters, using one of the most argued over questions in all of nutrition. Does eating red meat shorten your life? Instead of picking one method and publishing one answer, like almost every study before it had done, they tried something almost nobody had attempted in this field. They decided to run every single reasonable way of analyzing the data, all at once, and see what happens when you stop hiding behind just one method. First, they went digging through more than a dozen earlier studies that had already tackled this exact question, tracking tens of thousands of people over years of their lives. For each of those studies, they wrote down every single choice the scientist behind it had made, which statistical model, which factors they adjusted for, how they defined red meat in the first place. Piece by piece, they built something like a menu. Every defensible ingredient anyone had ever used to answer this one question, all laid out side by side. This whole approach did not actually start in nutrition science. It was born somewhere much messier, psychology. For years, psychologists kept publishing headline-grabbing findings that other scientists could not reproduce when they tried the exact same experiment again. Something in how results were being chosen and reported was clearly broken. So a fix was built. Instead of trusting one cherry-picked analysis, run every single honest one that exists, and let the full spread of answers speak for itself. Cherry-picking becomes nearly impossible. That fix worked so well at exposing shaky psychology results that a team eventually pointed it at one of nutrition's oldest, most stubborn arguments. So here is a question worth sitting with for a second. How many different ways do you think a completely honest scientist could analyze that exact same pile of survey data before running out of reasonable options? Take a guess, because the real number is almost impossible to say out loud. Combine every reasonable choice about the statistical model, the adjustments, the age group, and how you define a single serving, and you land on something close to 10 quadrillion different, individually defensible ways to analyze the exact same data. Obviously, nobody can run 10 quadrillion analyses, so the team narrowed it down to a huge but workable set, over 1,000 separate, fully justified versions of the same question, and ran every single one. What came out of that pile of results is the part almost nobody saw coming. That shift from one single confident answer to more than 1,000 different possible answers is exactly where this story gets interesting. Because whichever way you look at it, the debate around red meat has always been messier than the confident headlines make it sound. Some studies over the years have reported red meat raising the risk of an early death by as much as double. Others found no meaningful difference at all. A few have even leaned the other way entirely. Some of these studies tracked the same people for over 20 years, asking again and again what they had eaten, then waiting to see who was still alive by the end. That is an enormous amount of effort, and it still was not enough to settle the argument. That is not what science is supposed to look like. When something is truly dangerous, like smoking 3 packs a day, study after study tends to agree, loudly and consistently. When the results bounce around that wildly instead, it usually means one of two things. Either the true effect is small and easy to drown out, or the way scientists are analyzing the data is doing more of the work than anyone wants to admit. It is not really anyone's fault, in the usual sense either. No one is lying. Nobody is hiding data in a drawer. The disagreement comes from something built into the method itself, quietly, one reasonable choice at a time. This is also why untangling diet from health outcomes is so much harder than it sounds on paper. Nobody can lock a few thousand people in a lab for 30 years and control exactly what they eat. If digging into whether a famous scientific warning actually holds up is the kind of thing you enjoy, hit subscribe. There is a new one uncovered here every week. Doesn't it seem strange that so much careful, well-funded science could still end up this divided? Instead, researchers rely on people remembering and reporting what they ate, sometimes years earlier, then try to mathematically separate red meat from every other habit that tends to travel alongside it, like how much someone exercises, how much they smoke, or how much money they have for groceries in the first place. Every one of those adjustments is itself a judgment call, and every judgment call is another fork in the road that can quietly steer the final answer. That is precisely the fog this research group was trying to cut through, not by finding one more study to add to the pile, but by asking a completely different question. If you strip away the illusion of a single right answer, what does the honest, full picture actually look like? It matters more than it might seem, because studies exactly like the ones being tested here are the backbone of the official dietary advice handed to millions of people. A government pamphlet telling you to cut back on red meat almost always traces back to a small number of these observational studies. So if the method itself is shaky, that shakiness does not stay contained in an academic journal. It travels all the way down into your dinner plate. Multiply that shakiness across every dietary guideline built the same way: sugar, salt, dairy, and suddenly a lot of confident nutrition advice starts to look less like settled science and more like an educated guess dressed up as certainty. Around this point, you might be expecting the answer to slot into one of two neat boxes. Red meat is dangerous, or red meat is fine. Real science is rarely that tidy. By now, the team had over 1,000 separate, fully honest analyses of the exact same data sitting in front of them. So what did all of that actually reveal? The team pulled real health records for over 10,000 adults, tracked through a national database that records deaths across the country, and pointed every one of those honest, competing methods at that same data. Out of everything they tried, the typical results landed almost exactly in the middle. Barely any difference in risk at all, whether someone ate more red meat or less. Only a small sliver of those analyses, roughly 1 in 25, turned up a result strong enough to call statistically meaningful. And even that sliver split both ways. Most of those pointed toward red meat being slightly protective. A handful pointed the other way, toward slightly more risk. Put together, the overall picture did not lean convincingly in either direction. Statistically, it looked almost exactly like what you would expect if red meat had no meaningful effect on how long someone lives at all. There was, however, one twist buried in the numbers that nobody had fully expected going in. When the analyses were split apart by gender, a pattern showed up. Models that only looked at women tended to lean toward red meat being mildly protective. Models that only looked at men landed almost dead flat, showing essentially no relationship at all. The researchers are careful not to oversell that split. It popped up while they were exploring the data, not something the study set out to prove from the start, and a pattern like that needs to be tested on its own before anyone treats it as settled. Here is the honest caveat worth sitting with. Every single one of these analyses, all 1,000 plus of them, was still built on people remembering and reporting what they ate. That kind of data can show a connection between two things, but it cannot prove that one directly causes the other. What this research really demonstrates is not a verdict on your next barbecue. It is a warning about how fragile a single confident headline can be when it is built on just one out of over 1,000 equally reasonable ways to crunch the same numbers. The next time a nutrition headline declares something is definitely dangerous or definitely safe based on one single study, it might be worth asking the same question these researchers did. What would happen if you tried it 1,000 different honest ways instead of just one? You can find the full study this video is based on linked in the description.